If you stood in the middle of rural Egypt in the mid-20th century, the night fell with a heavy, absolute darkness. There were no municipal power lines spanning the fields, and no ambient glow on the horizon. Farming here required working around a brutal climate. To escape the severe, punishing heat of the daytime sun, agricultural workers had to route water through the irrigation canals and tend to their crops in the dead of night. Working the land meant relying entirely on manual labor. Farmers had to navigate uneven terrain, handle sharp iron tools, and walk along the edges of open water trenches with a visibility range of only a few feet. In this environment, access to portable light determined whether a farmer could maintain their livelihood or be forced into a dangerous standstill. The solution to that total darkness arrived in a small imported package, the Eveready D-size battery, identified by a distinctive logo of a black cat with 9 lives. Farmers loaded these heavy cells into rugged flashlights, creating a strong, reliable beam to spot pests, to deter thieves, and walk securely across miles of unlit dirt paths connecting isolated villages. These same batteries powered portable transistor radios, bridging a gap physical infrastructure could not reach. A single radio receiver pulled agricultural reports, weather updates, religious broadcasts, and music from the air, connecting farmers who spent all day alone in a field to a much wider national conversation. Distributed across a massive, unelectrified region, these small, self-contained units functioned as a decentralized portable power grid for a population living off the map. As the regional economy modernized, the demand for decentralized power moved from the farm to the heavy industrial centers of the United Arab Emirates. The oil industry relies on establishing massive logistical hubs and operating heavy machinery deep in the desert, often hundreds of miles away from the nearest municipal power station. Equipment in these isolated environments must run continuously. A failed battery in a remote dunescape represents a total operational shutdown. To meet this demand, manufacturers optimized internal grid designs for prolonged power draw and engineered materials for heat resistance. They also introduced Leitleibatuckers and specialized flame arresters into commercial truck batteries to ensure safety in volatile industrial workspaces. The entire Middle East's rapid industrial expansion was built on the back of this scaled-up, disposable power technology. Supporting this power volume shifted the burden of production to massive manufacturing hubs, specifically in Kenya. Entities like Eveready East Africa rely on massive economies of scale. To keep individual batteries affordable, they must maintain a relentless high-skate output. This massive production scale requires a continuous intake of raw materials, processing enormous quantities of lead, acid, and chemical additives. Generating portable power at this enormous, relentless magnitude consistently produces vast amounts of dangerous byproducts and highly toxic industrial waste. When battery ingredients and heavy metals escape into the soil or air, they contaminate local ecosystems and threaten the health of the surrounding communities. The tool that guaranteed human safety in the dark and drove industrial progress has become a systemic threat to the environment that produces it. Fixing this manufacturing crisis requires a framework called Green Supply Chain Management, or GSCM. The strategy treats environmental efficiency as an economic driver. By aligning ecological goals with business objectives, factories find that reducing energy consumption directly cuts their corporate overhead. This replaces the linear model, extract, build, dump, with a closed loop, viewing the supply chain as a single life cycle. Tracking batteries from extraction to disposal reveals hidden inefficiencies. This leads to source reduction, engineering waste out of production, leaving less to manage later. For manufacturers operating in a market that is increasingly sensitive to environmental costs, The logistics managed in a Kenyan factory determine the stability of the grid used by the Egyptian farmer and the UAE oil worker. Vast portions of the developing world still depend entirely on these decentralized power sources for their safety and their connection to the modern world. The battery's legacy depends on its supply chain. A technology built to bring light to the dark must now prove it can operate without poisoning the very ground it powers.